welcome to your second tutorial on balancing chemical reactions. This isn't really a lesson with new information. It's everything you learned in the first balancing chemical reactions video, but it's just an example of how to do more problem solving. So I'm just going to talk you through more examples of balancing chemical reactions. So let's get started. So here we have a reaction between sodium metal, Na, and water, producing NaOH and H2 gas. So I always start the same way. I always start by making a table where I list reactants first, then products, and I list all of the different compounds present in, or all of the different elements present in the chemical reaction. So I've got sodium, I've got hydrogen, and I've got oxygen. So now I need to go and count up how many of each element I have in the reactants and how many of each element I have in the products. So I have one sodium in the reactant and one sodium in the products. There are 2 hydrogen in the reactants. There are 1, 2, and 3 in the products. And we have 1 oxygen in the reactants as well as 1 oxygen in the products. So the problem really is with hydrogen, because we've got 2 hydrogens in the reactants and 3 hydrogens in the products. So I have to figure out what I can do to make these balance. So I know I'm going to need to increase the number of hydrogens in the reactants. So let's see what happens if I multiply the water by 2. So if I put a coefficient of 2 in front of the water, because that'll bring up the number of hydrogens in the reactants. 2 times 2 is 4. Now I have 4 hydrogens in the reactants. So I'll go to the other side. Is there a way for me to get 4 hydrogens in the products as well? Well, I've got 2 over here and 1 over here. So I can recognize that if I only need 1 more hydrogen, I can put a 2 in front of the sodium hydroxide, and that'll get me a total of 4 hydrogens in the products as well, because the coefficient of 2 means that I have 2 of each element in this compound. 2 sodium, 2 oxygen, and 2 hydrogen. So 2 plus 2 is 4. So now the hydrogen is all set. I have 4 hydrogens in the reactants and 4 hydrogens in the products. But the problem is that I've now changed the oxygen and the sodium as well. So when I put a 2 in front of the water, that changed things such that I now have 2 oxygens in the reactants, but I now also have 2 oxygens in the products. So that's fine. When I put the 2 in front of the sodium hydroxide, that means I now have 2 sodiums in the products. But I still only have 1 sodium in the reactant. So now I created another problem that I need to fix. Now the sodiums are out of whack. They're not in balance. 1 in the reactants, 2 in the products. But that's a really easy problem to fix, because I can put a 2 in front of the sodium, and now I've got 2 sodium in the reactants. So the coefficients for this chemical reaction are a 2, a 2, a 2, and then no coefficient in front of the hydrogen gas at the end. Double check that everything's in line. 2 sodium in the reactants, 2 sodium in the products. 4 hydrogen in the reactants, 1, 2, 3, 4 hydrogen in the products, 2 oxygens in the reactants, 2 oxygens in the products. So that chemical reaction is now balanced. So let's move on to the next one. So here we have a reaction between carbon dioxide gas and hydrogen gas, producing the organic compound called methane and water. So again, I'm going to start with my table. Reactants, products, and then I'm going to list each element that shows up in this chemical reaction. So I've got carbon, oxygen, and hydrogen. Count them up. 1 carbon in the reactants, 1 carbon in the products. 2 oxygens in the reactants, 1 oxygen in the products. 2 hydrogen in the reactants, 1, 2, 3, 4, 5, 6 hydrogens in the products. All right, so let's start balancing. Carbon, for now, is all set. 1 in the reactants, 1 in the products. So I'm going to check that off. Oxygen, however, you'll notice is not all set. I've got 2 oxygens in the reactants, but only 1 in the products. So I need to find a way to get 1 more oxygen atoms into the products. So H2O is the molecule that's got oxygen in it. So if I double the number of H2O molecules, if I put a coefficient of 2 in front, then that means I now have 2 oxygens. So that's all set. Now I know that when I put a 2 in front of the water, that also changes the number of hydrogens. So now I need to adjust the number of hydrogens in the products. 1, 2, 3, 4 from this compound, and now 1, 2, 3, 4 from this compound, because 2 times 2 gives me 4 hydrogens in total in the water. So 4 plus 4 is 8. Okay, so again, I need to balance this. I've got 2 hydrogens in the reactants, but I've got 8 hydrogens in the products. So I need 6 more hydrogens in the reactants. So I've got this H2 molecule, which is where my 2 hydrogens are coming from, but I need to get a total of 8. So I'm going to put a coefficient of 4 in front of the hydrogen gas, because I know that 4 times 2 will give me 8. So if I have 4 molecules of H2 in the reactants, that's a total of 8 hydrogens. And if I have 8 hydrogens, then hydrogen balances. 8 in the reactants, 8 in the products. Alright, so one more example. This is a reaction between aluminum metal, which is solid, and oxygen gas, producing a solid compound called aluminum oxide. So this one may seem a little simpler, in part because it only has 2 elements, aluminum and oxygen. So I'm going to count up. 1 aluminum in the reactants, 2 in the products, 2 oxygens in the reactants, 3 in the products. So I'm going to start with the oxygen, because 2 and 3 seems a little less intuitive to balance than O and 2. So here's a hint for how to balance a chemical reaction if you're stuck. I've got 2 oxygens in the reactants and 3 in the products. Look for the lowest common multiple between 2 and 3. So lowest common multiple, you might remember from algebra class, is the lowest number that's a multiple of both of these. So if I start listing multiples of 2, 4, 6, 8, 10, then I start listing multiples of 3, 6, 9, 12. The lowest number that's a multiple of both 2 and 3 is 6. That's called the lowest common multiple. So whatever number of oxygen atoms I end up with is going to need to be the same. It's going to need to be a multiple of 2 and a multiple of 3. So I'm going to start with seeing if it works if I have 6 oxygens on both sides. So 6 oxygens in the reactants and 6 oxygens in the products. So to get 6 oxygens in the reactants, I would need to put a 3 in front of the O2, because 3 times 2 will give me 6 oxygens. And I would need to put a 2 in front of the aluminum oxide, because 2 times 3 would also give me 6. So that balances. So I looked at the numbers 2 and 3, and I said the lowest common multiple is 6. So how do I get 6 oxygens on each side? And that worked. Now I need to double check the aluminum. Before I had 2 aluminums in the products. Now because I put a coefficient of 2 in front, I have 4 aluminums in the products, because 2 times 2 is 4. So can I get 4 aluminums in the reactants? Sure, it's easy. I just put a 4 in front, because this is just a single atom of aluminum. So if I put a 4 in front, that means 4 atoms of aluminum. And everything's balanced. I have 4 and 4, 6 and 6. And I can just double check that again. 4 aluminums. 4 aluminums. Right? Because 2 times 2 is 4. And 6 oxygens, because 3 O2s gives me 6. And 6 oxygens in the product, because again, 2 times 3 gives me 6. So now this is balanced. Here's one last example for us to go through together that's a little more complicated. And it's a little more complicated because, as you can see here, there are 4 elements in this chemical reaction. So let's start counting up. We've got 1 calcium in the reactants, 1 calcium in the products. I've got 2 oxygens in the reactants. This 2 after the parentheses means that there are 2 of each of those elements. So 2 oxygens, 1 oxygen in the products. I have 3 hydrogens in the reactants because I've got 1 over here and 2 over here. And I have 2 hydrogens in the products. Last but not least, I have 1 chlorine in the reactants and 2 chlorines in the products. Now, pause the video for a few minutes and see if you can actually figure out on your own how to balance this chemical reaction as practice, and then check your work with my answer once you're done. All right, let's see how you did. So calcium for now is all good, so I'm not going to change anything. So let's look at oxygen. I've got 2 in the reactants, so I want 2 in the products. So the easiest way for me to do that is just to put a 2 in front of the H2O molecule. And that doubles both of those. So now I go from having 2 hydrogens in the products to having 4 hydrogens in the products. And I go from having 1 oxygen to having 2 oxygens. So that takes care of the oxygen. Let's see what we can do about the hydrogen. I've got 4 hydrogens now in the products, right? 2 times 2 is 4, and I've got a 2 here and a 2 here, so that's 4. But I've got 3 in the reactants. 2 from the calcium hydroxide and 1 from the HCl. So I need 1 more. And I can do that because I can put a 2 in front of the HCl. Because the hydrogen in the HCl is just 1, if I double HCl, that gives me 2 hydrogens plus 2 hydrogens is 4. So now the hydrogen balances. But hopefully you noticed that I'm not just doubling the hydrogen, I'm also doubling the chlorine. So I go from having 1 chlorine in the reactant to 2 chlorine in the reactants, which is excellent because I had 2 chlorine in the products. So that's great. Now that balanced the last element for me. So again, I can go through and double check everything. 1 calcium, 1 calcium, 2 hydrogen, 2 hydrogen, 2 hydrogen. Oops, that didn't work. 2 hydrogen here. 2 hydrogen there is 4 hydrogens in the reactants, and 2 times 2 gives me 4 hydrogens in the products, and last but not least, chlorine, we already checked, 2 in the reactants, 2 in the products. Everything's all set.